Hello and welcome. In this video, let us solve a system of linear inequalities. System means that we will be solving two linear inequalities together. So here is an example. When we solve a system of linear inequalities, we solve each inequality separately, one at a time, and we shade the answers to each inequality, one at a time. Then we look for the place where the shadings crossed, because that's a place that is true for both inequalities. And that place where the shadings crossed, that region is the final answer to our system of linear inequalities. So once we find the region that is true for both of them, we erase all the other regions and leave on the diagram only the part of the region where the shadings intersected. So let's solve this inequality and see where the shadings crossed. The first inequality is x plus y is less than or equal to 2. The first step is to change the inequality into the equal sign and make a sketch, which would be x plus y equals to 2. Now let's solve this for the y, so we can use slope-intersect form. All we need to do is minus the x from both sides, and that makes negative x plus 2. The y-intersect is 2, which means our line is going to cross the y-axis at 2 right here. And then from this point, we use the slope to get the second point. And the slope is negative 1 over 1, which means the rise number is negative 1. So from here, we take one step down, and the number on the bottom is how far to go to the right. So from this point, we go 1 unit to the right, and that's our second point. So here are the two dots. Now we need to decide how to connect them. If we have equal sign in the original inequality, then we use solid line. If we don't have an equal sign, we use dotted line. This is going to be a solid line. So let's connect the dots with a solid line, which will look something like this. Now we need to decide which side of this line to shade, below or above. For this, we need a test point. Let's use the origin as a test point because the line did not go through it, so we can use this point. So using 0, 0, we plug in 0 for the x, 0 for the x, 0 for the y, and ask ourselves, is this true or false? Well, this says 0 is less than or equal to 2. Is that true or is that false? It's true, because 0 is less than 2, which means this is a true statement, which means all the points on this side, on the same side of our test point, all of these points will be true. So we will shade these points like this. So all of that will be the answer to our first inequality. Now let's go to the second inequality. We will use different colors to tell them apart. First step again is to switch to equals. 3x minus y equals to 3. Now we solve for the y. Minusing 3x from both sides will make negative 3x plus 3. To change the signs, we need to multiply all the terms by negative 1. So multiplying everything through by negative 1, we'll switch all the signs because we're looking for the positive y, not negative y. So the positive y is 3x minus 3. So this time the y-intersect is negative 3. So on the y, we go to negative 3, which is here. And then from this dot, we use the slope to find the second point. The slope is positive 3, so that means rise is plus 3, so we count 3 units up, 1, 2, 3, and run is 1 unit to the right, which puts us here. So that's the second dot. Now we connect them. Because the original inequality does not have an equal sign, these two dots will be connected with a dashed line, the dotted line. And the dotted line means that the points on this line are not actually part of the solution. Only the region that we shade is part of the solution. So now looking at this line, we need to decide which side of it to shade. This side or this side. And we need a test point that is not on this straight line. Once again, 0, 0 is not on the line, so let's reuse this point once again. So this time we use 0, 0 for the red line also. Plugging in 0 for the x, 0 for the y, makes 0 greater than 3, which is false, because 0 is not greater than 3. So which means all the points on this side of our line are false. All of this side is false, which means the other side, this side, is true. So now we shade this side of the red line. So this is the answers to the second inequality. And we'll look for the places where the two shadings crossed. We can see that this region on the bottom is the only part that is true for both inequalities. And that is the final answer to our inequality. All we need to do is erase all the other shadings and just leave with this. So our final answer will look something like this. Erase all the other shadings. This has to be gone the best we can. It's not going to be perfect, but it's a sketch. It doesn't have to be exact, but this is the general shape of our final answer. It's the region between these two lines, and that's where it is. So if we were to extend the first line a little bit further, if we wish, to make a bigger region, this is the final answer right here. And that's it. That's the final solution to our system of linear inequalities. That's a system, that's the answer. If you have any questions on this material, please let me know. If you have some of your own questions you would like to see discussed, also let me know. Thank you for your time. Look forward to hearing from you.